What makes a good data model? Is the process to communicate links between data and structures. A visual presentation of the entire information system or parts of it is created. Data models are built around business needs. This provides a common, consistent, and predictable way of defining and managing data resources across an organization or even beyond. Data models are lived documents that change as the business demands change. They are crucial in supporting business process as well as developing IT architecture and strategy. Conceptual data modeling. They are also referred to domain models and offer a big picture view of what the system will contain, how it will be organized, and which business rules are involved. Conceptual models are usually created as a part of the process of gathering initial project requirements. Next, it's logical data modeling. They are less abstract and provide greater detail about the concepts and relationships in the domain under consideration. One of the several formal data modeling notation system is followed. These indicate data attributes such as data types and their corresponding lengths and show the relationships among entities. Logical data models don't specify and technical system requirements. Next, physical data modeling. They provide a schema for how the data will physically stored within a database. As such, they're the least abstract of all. They offer a finalized design that can be implemented as a relational database, including associative tables that illustrate the relationships among entities, as well as the primary keys and foreign keys that will be used to maintain those relationships. Data modeling process. Different conventions govern which symbols are used to present data, how models are built up, and how business needs are communicated in data modeling. Identify the identities. The process of data modeling begins with the different identification or the things, events, or concepts that are represented in the dataset that is to be modeled. Each entity should be cohesive and logically distinct from all others. Second, identify key properties of each identity, which each entity type can be differentiated from all others because it has one or more than unique properties called attributes. Second, third, rather, identify relationships among entities. The earliest draft of a data model will be specify the nature of the relationships each entity has with the others. In the above example, each customer lives at an address. Next, map attributes to entities completely. This will be ensure the model reflects how the business will use the data. Several formal data modeling patterns are in widespread use. Object-oriented developers often apply analysis patterns or design patterns, while stakeholders from other business domains may turn to other partners. Next, assign keys as needed and decide on a degree of normalization that balance that need to reduce redundancy with performance requirements. Normalization is a technique for organizing data models or and the database they represent, in which numerical identifiers called keys are assigned to groups of data to present relationships between them without repeating the data. And lastly, finalize and validate the data model. Data modeling is an iterative process that should be repeated and defined as a business needs change. Oh, this second is Lastly, the types of data modeling. First, the hierarchical data models represent one-to-many relationships in tree-like format. In this type of model, each record has a single root or parent which maps to one or more child tables. Second, relational data models. Relational databases frequently employ structured query language or SQL for data management. These databases work well for maintaining data integrity and minimizing redundancy. They're often used in the point of sale system as well as for types of transaction process. Third, entity relationship or ER data models use formal diagrams to represent the relationships between entities in database. Several ER modeling tools are used by data architects to create visual maps that convey database design objectives. Next, object-oriented data models gain traction as object-oriented programming, and it became popular in the mid-1990s. This approach is employed in multimedia hypertext databases as well as other use cases. And lastly, dimensional data models were developed by Ralph Kimball, and they were designed to optimize data retrieval speed for analytic purposes. In a data warehouse, while relational and ER models emphasize efficient storage, dimensional models increase redundancy in order to make it easier to locate information for reporting and retrieval. That's all. Thank you, ma'am.